on here. Jeremy? The book, though, that's a check on the book being on here for number 11. I'm sure the book is on. Yeah. La book is el rongo. So you change, if you got this wrong, it should be, and again, remember, please, when you read this out loud, this is solved all the way for whatever purpose and reason it is. X is greater than -3 and x is less than or equal to 2. So when you do this, okay, when you do that, you should get here at -3, it is an open circle, and it goes to 2 with a closed circle. So they apparently, somewhere in the book, in errata, in error, they did it there. Lucas Spaniel?
But they both point the same way.
What's that? What do? Yeah, but notice how the x, and that's what will happen on all and problems. These arrows have to go, they have to go that way. If they were turned around and went the other way, there'd be no solution. Because then it would be x is less than this, which goes this way, and x is greater than that, which goes that way. And there's no way you can have an and problem like that. Because in order for and to be true, they both have to be able to be true. In this case, it couldn't be. You will always find that any compound and thing has both two less than signs. But because the x is on the wrong side or the opposite side where it usually is, that's what makes it actually a greater than sign. X is greater than -3. Now, speaking of that, number 16, children, I don't care if you got it right or wrong, I'm going to help you out here. Because we haven't talked about this. I have 6 2/3%. Okay? How do I change that to a workable number? In other words, it doesn't work. You can't really change it to a decimal because as a decimal it is 0.06 repeater, and you can't really work with repeaters because how do you multiply something by repeating 6? You can't really. So you need to figure out some way to change this to a fraction. And how do you know there is a fractional equivalent of this percent, but how do you figure out what that is? I mean, I can make it improper and it's 20/3, but that's still a percent. How do you make that? You're about to be enlightened, children. Well, here's what you do. Yes. Think about it if it weren't a fraction. If it was 6%, how do you make 6% a fraction? What do you do with it? You put it over 100 because that's what percent means, 6/100. Well, don't let fractions scare you. I'm going to take 6 2/3 and put it over 100 as well. Which at first looks like that doesn't make any sense, but it will. Change this to improper. What is 6 2/3 as improper? We did it up there. It's 20/3 over 100 over 1. Again, looks goofy, but can still be done because a fraction bar is nothing but division. 20/3 divided by 100 over 1. And how do you divide by a fraction? You flip and multiply. And then it kind of works out nicely because you end up with cross-canceling here and there. The fractional equivalent of 6 2/3% is 1/15. And you can multiply 1/15 times $24. So if you ever get stuck in a percent that you don't know what it is as a fraction, just put the whole thing over 100 and see if you can't work it out to be whatever it is. And there are some that you would never know. For example, if I did 1/18 as a percent, you probably wouldn't know, but to flip it back, you'd have to do it that way. Emma Haynes?
How'd you multiply the 115?
It'd just be 1/15. It would be 1/15 times 24. Because that's what you want to know that of that. So then you could cross cancel. It would be 3 goes into this 5 times, 3 goes into that 8 times. So it's 5 into 8, or $8 as it would be. Which would be $1.60. 5 into $8. 6%. 6 2/3%. There's some tough mathematicals there, Lucas.
You need number 17?
I wish I could. Oh wait, look at that's changed too. Now it doesn't look like a big round thing, it's actually an eraser. Little surprises around every corner. quote unquote. Willy Wonka, thank you. Oh, yeah. Alright, Lucas, first thing you gotta do is
Multiply the 3 in the parentheses.
distributive property, right? So I end up with 3x plus 3 minus 2x equals 2. Now what?
You take out 3.
Well, you've got a 3x and a minus 2x, put those two together, they're on the same side of this equal sign, you get what? We get just 1x.
And then you minus 3.
You just subtract your 3. 2 minus 3 is a negative 1. By the way, while we're sitting here, children, problem number 18, which actually was not difficult to do as a fraction. Remember what I said, if you don't like to do the fractions, what would I multiply everything by to get rid of a fraction? John? 100? No, that's a decimal. Fractions are different. We talked about this. How can I get rid of these fractions? Multiply by, Jeremy? The common denominator. If I multiply all these by 12, if I take 2/3 x, multiply it by 12 over 1, if I take 1/2, multiply it by 12 over 1, and if I take 7/12 and multiply it by 12 over 1, I am going to get all of the fractions that completely cross out. Because 3 goes into 12 4 times. 4 times 2, I get 8x. 2 goes into 12 6 times, so I end up with plus 6. And 12 goes into 12 once, equals 7. So that whole thing, that whole equation turns into this equation. You subtract your 6, you subtract your 6, you get 1. Divide by 8, I'm going to guess the answer was 1/8. Now, this one wouldn't be that hard to do as a fraction. Did I get it right? Yeah. You could subtract 1/2 from that, which is 6/12, so you end up with 2/3 equals 1/12. And then you automatically know how to get rid of a fraction in front of a letter. Multiply by its reciprocal. And you'll still get 1/8, but I'm just saying, make your life a little easier at times. Jackson?
I'll find you number 19.
19 was, again, notice there's no equal signs here, children. So you're not going to get an equals thing. You're just going to simplify as much as you can. That's why it says simplify. Jackson, did you do distributive property?
No, but it'd be 3x plus 6.
3x plus 6 plus 2 times x is 2x. 2 times negative 3 is negative 6. Putting together your 3x's and your 2x's gives you 5x's. A 6 and a minus 6 is nothing. So there is your simplified answer there. Austin!
80.
I would love to do 10.
20.
Huh?
Is it 20?
Oh, I would love to do 20. Couple thoughts on number 20 are this. First of all, you can multiply this together to get what? 3 times 15 is 45. This is the square root of 45. Now, the reason why you might not want to do that necessarily is because to simplify the square root of 45, you got to break it down anyways into what times what gives you that. So really, you're going to end up doing this. You're going to break it down into the square root of 3 times the square root of 15, and the square root of 15 is the square root of 3 times the square root of 5. So really, you didn't have to multiply it because you're going to break it down again. You could have just broken this down and see. 2 square roots of 3 give you a normal 3. There is no other match for the square root of 5, so it stays the square root of 5. And if I asked you what 3 times the square root of 5 would be close to as a whole number, you would tell me, if you were guessing, if I gave John 3 times the square root of $5, about how much money would I be shucking out? Somebody must be able to tell me somewhat close. Jeremy? Oh, it's got to be more than 5. If this was the square root of 4, it'd be 2. And 2 times 3 is $6. So it's a little bit more than the square root of 4. So it's got to be more than 6, less than 9. So I would accept anything between 6 and 8 probably or so. John?
Number 2, what kind of formula would we use again? I forgot.
We would use the correct formula. Where is that music coming from? Alright, 2 is not a formula so much as it is a proportion problem, equal ratios problem. And this would be one you want to write down here, kids, because I'm sure it's going to be. What I would first start doing is I would redraw the similar triangles. In other words, you've got this small triangle right here. It is similar to this big triangle here. Oops. Which is this. Those are your 2 similar triangles. What are the dimensions? This is 50, this is 30. The problem tells you that CB is 54. And they want to know what this side over here, which I'm not given, is. Okay, and proportion just means that corresponding sides are going to be proportional. In other words, 30 on the small triangle corresponds to 50 on the big triangle, and that's going to equal 54 on the small triangle, which corresponds to what you don't know on the big triangle. So just equal fractions there. And then it's up to you how you want to solve this ratio, fraction, whatever thing. What would suggestions? I would, Jeremy? Alright, I'd reduce this down to 3/5. Then, Joe Hammer? What's that?
You divide 54 by 3, and then
Does that work? Sure. Sure.
18.
You can just cross multiply 3 times x equals 5 times 54, or as Nikki Collis said, she knows that 3 times 18 is 54, so 5 times 18. That's probably what Cohen was going to. 90. That would be fun. So this is 90. This is not a Pythagorean theorem thing because you didn't know 2 of these 3 sides. Now I could use the Pythagorean theorem now to find this side. Nor I really can't use the Pythagorean theorem. Why? It doesn't tell me that these are right triangles. So I really couldn't do that. It doesn't give me the little triangle thing, nor does it tell me it's a right triangle. So you really couldn't use the Pythagorean theorem there at all. Nick?
Can you found 8?
Oh, not 8. Write an expression for the perimeter. No, Nick, the first thing I would do is, the perimeter of the triangle is side 1 plus side 2 plus side 3 plus side 4. You just need to add x minus 1 plus 2x plus 3 plus x minus 1 plus 2x plus 3. Put all your x's together. 1x, 2x, 1x, 2x, that's a total of 6 x's. Minus 1 plus 3 is plus 2, minus 1 is 1, plus 3 is 4. That would be the expression. Same thing for number 9. Do I need to do number 9? Really?
Yeah.
The area of a rectangle is length times width. So the area is going to be x minus 1 in parentheses times 2x plus 3 in parentheses. It's a binomial times a binomial, in which case we would use the ever popular FOIL method. 2 first terms is 2x squared. Outside term is 3x. Inside term is minus 2x. And the last term is minus 3. These 2 will combine to give you just an x. So we end up with a 2x squared plus an x. Plus an x minus a 3. Schwartz, where'd you go wrong? Accidentally or on purpose? Did anybody ever do a problem wrong on purpose?
Yes, I did on Tuesday. In Spanish.
Did you?
Yeah.
So everybody had to run? Yes. That's good, but it was good for everybody to do that. Jackson?
For number 9, what was that thing that said 2x squared plus 3x minus?
Wait, for this?
Yeah,
It's just whatever one side is times the other side.
yeah, but like right there, it says 2x squared plus 3x minus.
Minus 2x plus minus 3. Minus 2x comes from the two inner terms. Negative 1 times 2x is negative 2x.
Okay.
Negative 1 times positive 3 is negative 3. This is probably more fun to go with anyway. Alpha? El número cuatro. And these would be things you would probably put in your notes. The height of the cone is 12 centimeters. What is its volume? They gave me the height. Well, let's just draw the height over here. Height is 12 centimeters. Remember, cones and pyramids get cut or divided by 3. So here's the formula for the volume of a cone. The volume of that cone is the formula for a cylinder divided by 3, because that's what a cone is. It's actually put inside of a cylinder. And the cylinder is simply pi times radius times height, all divided by 3, because it's a cone. And they give you all the stuff you need to know, just gotta be careful here. Volume equals 3.14 times, what's the radius, Allison? 5 times 5 times the height, which is 12, all divided by 3. And once again, the book is very nice because it gives you nice numbers to work with. I can divide 3 into 12 4 times. And doing this multiplication here, 4 times 5 is 20. 20 times 5 is 100. 100 times 300, or 3.14 is 314 centimeters cubed. That was mighty nice of them, don't you think? Thank you, book. And people, Mr. Stephen Take, is that his name on the book? You wouldn't know because, well, maybe you would. Because it doesn't say anything. Emma Kreis.
You didn't get 13.
I would more than love to do 13. Yeah. 13 again would be something you definitely want to jot in your notes. Oh, children. Okay, these are linear equations. In other words, when you graph them out, they become lines. Okay, and these two here, both of these are given in what we called back in the day slope-intercept form. Anytime an equation solved for y and it has x on the other side, okay, it's slope-intercept form. Well, you just have to remember that y equals mx plus b. Okay. This letter b, the number at the end, the 3 and the -1 are where it crosses the y-axis, and the numbers in front of the x are the slope of the line. I know it scares you that there's no numbers in front of the x, but when there's no numbers in front of the x, there's always a 1 in front of the x. So when you do this, when you graph this, this is what it would look like. And again, you really need to do this on a piece of graph paper or on the test thing. If you want to get a different piece of graph paper, do it, that's fine. For this one here, who asked me this? Emma Kreis, where does it cross the y-axis? At -1. And then from that point, it's a +1 slope. +1 slope is a 1 over 1, which means it goes up 1 over 1. Up 1 over 1, up 1 over 1, up 1 over 1, and you continue to get that line right there. That's the first line. The second line, Emma Kreis, crosses the y-axis at 3. 1, 2, guess I'm a little off on that. 3, and it has a -1 slope. That's still up 1 over 1, but it's up 1 over 1 the other way, or down 1 over 1, it doesn't matter. Okay, so it goes down 1. Not so sure what the thing is in here. I think this is supposed to be here. It goes down 1 over 1, down 1 over 1, down 1 over 1, and you get this line right here. And the place where those two lines cross, which in this case was 2, 1, is the answer that fits both of those equations. That's right. Sometimes it's tough. Nichols?
Number 13, don't you only need to draw 2 dots? Like you don't need to draw like 4 dots.
Well, generally speaking, 2 dots can get you in trouble. Yeah, I suppose when you're using slope intercept, yes, 2 dots. 2 dots are about all you need. If you're doing a table, you need 3, I suppose. Now, there is another way we graph. Does anybody remember doing the XY intercepts? Then you can only do 2 dots, but we won't go into that now because that'll just throw us through. Austin?
Number 3.
How does number 3 sound familiar? Ah. Is that 7th grade school second?
Yeah.
They are a light and minor group, aren't they? Alright, Austin, this is a percent discount problem, right, Austin? And how do we show on a percent box, percent discount? You start with your original price, you subtract the discount, and you end up with your final price. Now the beauty of this is it said to estimate. So we can use our numbers and round them a little bit to figure out, make it easier. Austin, what was the original price? Which we would round to? $50. Do we know the discount, or do we know how much you finally paid for the thing? Huh? $40 is the discount, or what the final price was? Okay. So if I know the final price, is that $100? If I know the final price is $40, Austin, how much was the discount in money terms? $10. Now what do I know about their percentages? The only thing I know about the percentage is the original percent is always 100%. And I want to know the discount percent, not the final price percent. So I want to know this one. So that's just a pretty simple little fraction ratio equivalent thing here. I can go from 50 to 100 by multiplying by what, Austin? 2, and I can go from 10, multiply it by 2, that's my percent discount. That's where 20% comes from. Right now, we would be out there with Jackson trying to throw his club across the perfection. Is that thunder?
No, it's 8th grade, or something. It sounds like 7th grade.
We should sing the 500 like that.
You should be defended by some.
How many?
Oh, you were here for music ed.
Oh, I thought we just about did all these things here.
Was it a
Lauren, did you have a question? Or Nikki Cal.
Well, I have 2 questions. For the axis, is the y going up and the x like this?
Yes.
And then,
Y-axis is the one, the vertical one. X-axis is always vertical.
and then I'm fixing on 14. I normally get these from 45.
Number 14, great. The one that I put the box over.
Just erase everything.
I'm gonna move the box up. Number 14, ladies and gentlemen, actually is a good one. I kind of like this one. Number 14, I like this because it shows you the beauty of that unit multiplier or conversion fraction things. Okay, you want to change 40 meters per minute into kilometers per hour. Did I do something wrong?
It's 400.
So the answer would be yes, I did do something. Thanks for pointing out my flaws, John Nyer.
Anytime.
I hope you make a mistake sometime. So, because you're changing 2 labels, Lucas, because you're changing 2 labels, oh, you're just staring over them. Because you're changing two layers, you have to use two unit multipliers. One of them's gonna change minute into hours, and one of them's gonna change meters into kilometers. And it doesn't matter which one you do first, let's just do meters to kilometers. If I'm changing meters to kilometers, since it's on top, I have to put meters on bottom and kilometers on top. And you should hopefully know by now that there are 1,000 meters in 1 kilometer. This is our unit multiplier conversion fraction slash whatever. Did I do something wrong again?
Actually, John did mess up because I had to show him.
Okay. So he is. Okay, so right now I have changed this into kilometers per minute. Okay, so now I just need to use one more unit multiplier to change this minute into hours. Minute has to go on the bottom or top, so it crosses off here. Hours have to go on the bottom. There are 60 minutes in 1 hour. So I have now actually did it. I just need to do the math stuff. The stuff on top is 400 times 60 over 1,000 on the bottom, and it will be in kilometers per hour. And this is pretty simple because you can cross off 1 0 with 1 0, a second 0, another 0, third 0, 4 times 6. 24 kmph, kilometers per hour. Sage.
I just guessed on the time.
Did you get it right?
Yeah.
Well then why mess with that? Guessing won't get you, I'm guessing it must have been an educated guess. I'm guessing that's on this page over here somewhere. Well, number 10, you definitely, children, want to have your little numbers chart with you. Subset means that it's, if you look at the numbers chart, do you think I can find it here somewhere? Yeah. Where's the vote of confidence here? Here. Look for something that says real numbers chart. Maybe it's not in this one. Hold on a second. It might just be under my real numbers. Or just under numbers.
Real?
No. Where? So small, right?
Real
Right here?
Yep.
Give it a second. Alright, Sage, so you really need to be looking at this, Sage. And what was the question was, name a subset of what numbers? The whole numbers, right?
Yeah.
Okay, now what you have to understand is, subsets mean that it's a set inside of a set. In other words, our biggest box here is the real numbers. Everything in the real numbers is a subset of the real numbers because it's all found within it, okay? If I asked for a subset of the rational numbers, you would have the integers, the whole numbers, and the natural or counting numbers. If I asked for a subset of integers, it'd be the whole numbers and the natural or counting numbers. They asked you for the subset of, can I have a flash photography, please?
Is this,
Did it go? Maybe it doesn't work anymore.
I get it now, I
no.
get it now.
Okay, there, Sage. They wanted a subset of the whole numbers. Well, the only set that's inside the whole numbers is this one. The natural or the counting numbers. There's not much smaller than that. Am I right?
Maybe problem 5.
We must be getting close, are we? Close to doing it all?
That's not seventh grade.
Is it?
Yeah, it is.
No, it's so 6th grade. Yeah.
Oh, yeah. I'm surprised nobody asked about this. Why is nobody asking about this? What is the slant height of the cone in question 4? I'm going to guess that the cone was this thing that had a height of 12. I'm sorry, I'm going to redraw that if that's okay with you. The directions said that it had a height of 12, and this bottom was 10, I believe, right? Okay. Now, the only way to find that slant height, who asked me this? Emma Haynes, is you want to pretend like you slice this cone in half. Matter of fact, I'm going to make this a dashed line. Okay, pretend like you have a cross section of this cone and make a right triangle that goes right down to the middle, straight across to the edge. So here is a right triangle in the middle of that cone. We know that halfway through is 5. We know that the height from bottom to top is 12, and the slant height would be the hypotenuse of that triangle. And we hope, besides the 7th graders stop singing, that it's a triple. Because if not, then we're going to have to do some work. Is there a 5, 12, hypotenuse 13? And that's where that comes from. Number 6 while I'm sitting there? Jackson? 6. Jackson, let me ask, did you take your time and redo everything step by step? In other words, did you do this? Did you go b squared minus 4 times ac, Jackson? And then did you fill in the blanks with a b is 5, a is 1, and c is at a negative 6? Did you do that, Jackson? Alright. So Jackson, now we have what is 5 squared? 25. What is a negative 4 times a negative 6 times a 1? Positive 24.
Minus a negative.
What? Yeah, minus a negative 24 is plus 24. Two negatives multiplied together, you can do positive. So you end up with the square root of 49. And do not forget, square root, if you say something equals the square root of 49, okay, there are 2 different numbers that will give you a positive 49. 7 times 7 gives you 49, as well as negative 7 times negative 7. So you should have 2 answers there, 7 and negative 7. Generally speaking in math, though, you always go with positive square roots, generally speaking. Unless, you know, they tell you, unless they do this. If they want both, usually they do this. They put a plus or minus sign in front of it, one positive and negative. How many more was that left? Them Haynes. Oh, 7's a good one too. Emma Haynes. It said the dimensions of a cube are doubled. What did it tell us the dimensions of that cube that was doubled was? What are the dimensions of that cube?
Just 2 times, stop singing that.
Okay. Who's the ding ding ding?
I have a special sentence made for just sort of thinking. Because before 8th graders, while they're trying to study for their math test, I cannot do it when you're outside my room yelling all the time.
I seriously, that was a fact. Seriously,
That doesn't work. That's it. You can invite yourself to each other's house and sing all you want.
Back to your question there, Maheen. Sorry about that. We're about done here. Number 7, which I'm surprised other people didn't ask about. What dimensions does it tell you the cube is?
You gave us the it's double the volume.
What's that?
It's just double.
No. Don't get ahead of me. I asked you what dimensions does it tell you the cube is? It doesn't. Which means, Emma Haynes, that you get to pick what you want to double. Now, don't just assume, kids, because we talked about that, things get goofy with area and with volume. Don't just assume that because the dimensions are doubled that everything else is doubled, because that's not the case. And in this case here, I am just for fun going to pick 10. Just because I picked one with everybody else that came and asked me this question. And that means if I have a cube that is 10 centimeters by 10 centimeters by 10 centimeters, and I double those dimensions, my new cube is going to be what? Right. My new cube is going to be 20 centimeters by 20 centimeters by 20 centimeters. But we're talking about what happens to the volume here. What is the volume of a 10 by 10 by 10 cube? Okay, this is 1,000 centimeters cubed. What's the volume of my new cube? 20 times 20 times 20? 20 times 20 is 400. 400 times 20 is 8,000. And the question was, how many times bigger is the new cube than the old cube? In other words, what would you multiply the volume of this one by to get the volume of that one? 8. Now, how does that work? Again, okay, when you double something, but its volume, you're not doubling it just once, you're doubling a second dimension and you're doubling a third dimension. Okay, you are doubling it 3 times. And that's where, that is where you end up with 2 to the 3rd power times bigger, which is, did I put it in there backwards? Which equals 8. Now when area is doubled, because you're only doubling 2 dimensions, when you only double 2 dimensions, you're only doubling it twice. That's why it's 4 times bigger when you talk about area. Okay? So the question I have for you is this. Let's say if you quadruple something. If you quadruple something's dimensions, make everything 4 times bigger, how much bigger will the volume of something that you quadruple be? Because you are quadrupling 3 different dimensions. For inch shell hammer? No. You are quadrupling 3 different dimensions. It would be 64 times bigger. The volume of it would be. The area would only be 16 times bigger. It's not an easy thing for people to get. Back to the test. Oh, I guess it's yours. Is that all? One?
15.
15.
Anybody on number 1?
Wait, I'm 15 and what is it?
For number 6, you said it's 7 and -7, -7 and -7 for 12.
What was 12? Actually, I think the book just said 7, didn't it, for 6?
Yeah.
I don't think it actually put a 7. Don't worry about it. What number 12?
12 is 7 and
7, 12 was the one that I said 7 and -7. Either, don't worry about it. Either, I'll give you, I won't mark that one. Jackson?
We'll do number 15.
Which one?
15.
15. I don't even remember, I didn't even read this question before. 2 number cubes are rolled at the same time, what's the probability that both number cubes will show an even number? You've got probability, you've got cube number 1 and cube number 2, and you're looking for the probability that you will get an even, 2 even numbers. Alright, Jackson, so you have to take the probability of rolling an even number on the first one. How many even numbers are on a cube? How many sides are on a cube?
There's 3 even.
Right, 6 sides to a cube, right? How many, if you roll that same cube again, how many sides, how many cubes? The probability of both of them happen are these things multiplied together. This is the same as 1/2, that's the same as 1/2, so you end up with 1/2 times 1/2, which is 1/4 of the time you should get 2 even numbers.
Right.
Number 16, very did it, but how did you do the 20 over 3 over 100?
How did I do it? It's probably worth doing this again. So it was this. You do it big and slow. because it's a good thing for everybody to know. What does percent mean? Out of 100, right? So, I want to know what 6 2/3 out of 100 is. Okay? Really, maybe Christ, it would work better if I just wrote it like this. This is 6 2/3 divided by 100. So it's 6 2/3 divided by 100. Make this improper, it's 6 times 3 plus 2 is 20 over 3 divided by 100 over 1. And then how do you divide by a fraction? You multiply. 20 over 3 times 1 over 100. And then some cross canceling. 20 goes into 20. You end up with 1. That help? It's a good thing because if you ever found one, I should try one on you. You know, if it was like 7 1/5% and you wanted to figure out what fraction that really was. Actually, which would be a fraction? For 7 1/3%, it has to be a fraction. 7 1/3% would be what fraction? So it's probably not going to be a nice one, but it's got to be something over. It's 22 over 3 times 1 over 100. 22 300ths would be the fractional equivalent of that. Doesn't reduce at all. You like that, don't you? Sage.
I still like it on my.
One more time on number 18. What about it, Sage?
I don't know, I think the number.
Well, let's do it, Sage, let's do it without the cross canceling thing. Let's just do it straight up. What do you, if this is just your equation, Sage, how do I solve that for the letter x? Did you do that?
Yeah.
So 7/12 minus 1/2, and 1/2 is the same as what? How many 12s, Sage? 6/12. So 7/12 minus 6/12 is 1/12. So now I have 2/3 x equals 1/12. How do I solve when there's a fraction in front of a letter? Just flip and multiply. If I multiply by 3/2, I multiply this by 3/2. It ends up being 3 over 24, which you can reduce down to 1 over 8. Jeremy? I was just checking to see if it makes sense. 11 over 150. For those of you in TV land, Jeremy caught me. First it's John, now it's Jeremy. And Jack got a lot of humor out of that.